right, for today's lesson, we're going to be talking about polynomials. A polynomial, the prefix means many, but a polynomial is the expression with one or more terms. So what is a term? A term is when I have any letter or number, so variable or number, that is separated by addition or subtraction. So when I look at this, if you can see highlighted in green, I have three separate terms. So I have 3xy is one term, 4x is another term, and 1 is a third term. And they're all separated by addition or subtraction. So I have three terms, and they're separated by addition or subtraction. Now, we have a more detailed name for 1 through 3. So if I have just one term, then we call that a monomial. So just one term would just be 3xy by itself. A binomial means two terms. So I could have 3x plus 1. That's two terms. A trinomial means three terms. So I could have 3x squared plus 5x plus 1. And again, these can be formatted in multiple different ways, but just so that you know from now on, a polynomial means an expression with one or more terms. A term is separated by addition or subtraction. Mono, for the prefix, means one, so one term. Bi means two, so that's going to be two terms. And trinomial, tri, means three, which is going to be three terms. Now, the only other thing that I wanted to identify here is a couple of things as far as how to put a polynomial in standard form, and then what are some things that we can identify about that polynomial. So to put it in standard form, you're going to order your exponents. So we're going to order our exponents from greatest to least. So we're going to order our exponents from greatest to least. So when I'm looking at this one, my largest exponent goes with the negative 9x to the fifth. So we're going to start with that one. So we brought that term down. The next one is going to be 8x to the third. So we're going to write that one next. Then minus x squared, and then plus 10. My constant is always going to be the last one. So when I say constant, the constant is always the number without a letter, so a number without a variable. The number that's being multiplied in front of the polynomial in standard form now is the leading coefficient. And then the largest exponent is called the degree. All right, so I'm going to say that again. So we have the constant is the number without a variable. I have my leading coefficient, the number that's being multiplied in front of the whole standard form polynomial. And then the largest exponent is the degree. All right, so if I do another example, let's look at, so for this one we have 5x to the fourth, that's going to be my largest. Then we have minus x to the third, then plus 4x plus 1 over 6. So again, I have my constant, that's going to be my 1/6, that's my number without a variable. My leading coefficient, I'm going to just put LC, is 5, and then my degree is my largest exponent, which is 4. So just a few things to keep in mind. And again, when you put your polynomial in order, you always put in order with the exponents going greatest to least. All right, so what we're going to do is we're actually going to do some adding and subtracting. Hopefully this should be a very easy topic. But in order to add or subtract, you got to make sure you know what your like terms are. So when I'm looking at number 1, I can only add together same variables with same exponents. So when I'm looking, I have 3x. So I'm going to kind of zoom here. 3x and negative 6x. So that's going to turn into negative 3x, because 3 minus 6 is going to be negative 3. And then I have negative 2y and positive 4y, so that's going to be 2y. All right. So second problem that we have up here. So I have 4z and 3z. So that's going to turn into 5z. And then I have 2t minus t. Now that's a minus 1. So this is going to become plus 1t, or just plus t, because 2t minus 1t is going to be t. All right, and our third problem, so we're going to add together 8a and 6a, so that's going to give me 13a. And then we have 6b and 2b, so add those together, and that's going to give me 8b. All right, so now what we're going to do is we're going to step it up, but it's really not going to be any harder than what we just got done doing. We are going to add and subtract binomials and trinomials and all types of polynomials. The key here is making sure that you combine like terms and then you put it in order in standard form from greatest to least. So when I look at this problem, I see that my first example, I'm adding between the two parentheses. So if I'm adding between the two parentheses, that means that I'm going to add 4x and 7x, and then negative 3 and 8. So 4x and 7x are going to combine, and those are going to make 11x. And then negative 3 plus 8 is going to give me positive 5. All right, now for the next one. For the next one, I can see that there is subtraction between here. Now, what I recommend is distributing that negative. And the reason I recommend doing that is because a lot of the times I see students make the mistake, they forget to subtract this second number over here. They'll subtract the first term, but they'll forget to subtract the second term. But if you go ahead and distribute the negative, then it's going to turn into addition, and then I have negative 2x minus 6. So then we have 3x and negative 2x, so those are going to combine to make just 1x, or x. And then we have negative 4 and negative 6. So negative 4 and negative 6 are going to make negative 10. Next one, we have 3. So we have a trinomial plus a trinomial. So again, we're going to be adding. So I'm going to add, I have 2x squared and 4x squared. So that's going to make 6x squared because we're adding the coefficients. All right, and then for the next one, I have negative 8x and 12x. So that's going to give me plus 4x. And then finally, I have 3 and negative 5. So that's, so 3 minus 5 is going to give me negative 2. Now, so far everything we've done is kind of matched up as far as the like terms were in the same spot that they always should have been. That's not necessarily true though. So I have 5x squared first here, but then I have 6x first here. So sometimes I'm going to have to be very careful and see that 5x squared should go with negative 9x squared. So we have negative 4x squared. Now, these two right here are not like terms, so I'm simply going to bring those down so that they aren't combined, but they're still part of the polynomial. Okay, so looking at number 9, I can see again that I have subtraction, so I'm going to distribute. So I have x squared minus 8. I'm going to change that to plus negative 7x plus 4x. So negative 7x minus 4x squared. So I have x squared and negative 4x squared. That's going to give me negative 3x squared. And again, I don't have like terms with the last two, so I'm going to bring them down in order. So negative 7x minus 8. And number 10. So this time I have two parentheses. So I have an addition sign here, and I have subtraction here. Now when we distribute, that subtraction is only going to go to the parentheses directly behind it. So we're still going to have 5x to the third minus x plus 2x squared plus 7 minus 4x. We're going to change this to addition and distribute the negatives. So it's going to be negative 6x squared minus 5x cubed plus 3. And now we're going to identify our like terms. Now for this one, we're actually starting with a higher exponent, so we have x cubed. So I have 5x cubed and negative 5x cubed. So that's actually going to equal 0, so those are going to go away. All right, for my next one, I have 2x squared and negative 6x squared, so that's going to give me negative 4x squared. All right, and then I have negative x, or negative 1x, negative 4x, and that's going to turn into negative 5x. And then finally, we have 7 and 3 to give me plus 10. Now, for 11 and 12, these are actually set up horizontally so that it's like adding when you did basic addition with regular numbers without variables. The only thing that you have to be very careful of is you have to make sure your variables of like terms line up correctly. So x squareds are always in a column together. My x's are always in a column. My constants are in a column. So like right here, this one is not lined up correctly because I have 5x squared and I have 3x under it. This should be under here. So if I were to add these two up, this would be 3x squared plus 2x and then plus 1. Now for this one, I would still need to distribute my value of negative. So let's go ahead and make that subtraction. But when I rewrite it, I want to make sure that my variables and exponents line up correctly. So I still have, so I'm going to have plus, and that's going to turn into positive 2x cubed. I have nothing here, so I'm going to leave this blank under x squared. This is going to turn to negative 3x and then positive 4x. So again, we have nothing under the x squared. So when I combine these two right here, that is actually going to become 0. Those go away. I'm going to bring this down because I'm not adding it with anything. And then I have negative 1 plus negative 3x is going to give me negative 4x. And then 8 plus 4 is going to give me 12. Now, in doing all this, you're going to see a lot of perimeter problems. So when we talk about perimeter, we think about the sum of the outside of a problem. So you're going to add up all the sides. If it's a triangle, then you add up 3 sides. If it's a rectangle, you add up 4 sides. No, it doesn't matter how many sides it is, you always add them up. So it's the same thing as adding polynomials. Because I have, in my problem here, I have 3 sides, and I have 3 different polynomials that I need to add up to find the perimeter. So if I identify my like terms, so I have 4x and negative 2x, and that's going to give me positive 2x. I have just a single y, because I like to look at my variables first. I'm going to bring that down. And then I have negative 8, 3, and 11. All right, so we have 11 plus 3 is going to give me 14. 14 minus 8 is going to give me plus 6. So my perimeter is 2x plus y plus 6. All right, so let's look at the next triangle. So for this next triangle, I should be able to see that this triangle is actually got all the same sides. So I can still add them all up, or if they're all the same, I can multiply it by 3. So if I multiply it by 3, that's going to give me 9a minus 3b, which would be the same thing if I had added 3a, 3a, and 3a to give me 9a. And then negative b, and negative b would give me negative 3b. All right, so the last example, or last triangle example, if I'm doing perimeter, is I have I'm going to start with my x's. So I have negative 3x, 9x, and 5x. So when I add that together, so I have negative 3 and 9 is going to give me 6x. 6x and 5x is 11x. All right, so then I have 2y, negative 3y, and 7y. So 2y and 7y are going to give me 9y, minus 3y is going to give me plus 6y. So again, I'm just adding or subtracting the coefficient. And then finally I have negative 3, 2, and 12. So negative 3 plus 2, that's going to give me negative 1, plus 12, that's going to give me plus 11. All right, so let's look at the next example. So I have a rectangle here. Now, they have only given me 2 sides of this actual rectangle. So the most common mistake that students make is they only add up these 2 sides. But that is not going to give me my whole perimeter. I have to add up all 4 sides. And if I know the properties of a rectangle, which you should, then you should know that opposite sides are congruent. So now I'm going to be adding up all 4. Okay, so I can now combine my like terms. So I have 5x squared and 5x squared. That's going to give me 10x squared. So I have 3x and 3x. That's going to give me plus 6x. And then I have 7. Whoops, I copied that one wrong. So let's take away that x. That should be just a plain 7. So I have 7 plus 7 minus 2 minus 2. So basically I have 14 minus 4, which is going to be plus 10. All right, so the same rule applies for the next one, except for I can see that this next one is going to be a square. I have 2 sides that are equivalent. I have 4z plus 3. So I also know that this one is 4z plus 3, and this one is also 4z plus 3. So what I can conclude about the rest of it is it is a square. So I can actually conclude that all 4 sides are congruent, and I can say 4 times the side length. So 4 times 4z, 4 times 3, so that's going to be 16z plus 12, which again, if I combine them all together, 4z, 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 and 4z is going to give me 16z, and then 3, 3, 3, and 3. So just don't forget, if they give you 2 sides, don't forget that if it's a rectangle, that you're going to have to add in the rest of the sides to this problem. One of the most common problems that they like to give you on your EOC is they actually like to give you the problems that require you to work backwards. So what I mean is they give you a problem where they actually tell you the perimeter. So they're saying that they know the perimeter already. The perimeter is 10a plus 3b plus 12. And they know that one of the sides is 3a plus 8. And the other one is 5a plus b. But it's a triangle, so they want us to find the third side. The third side is what's missing. So if I were to draw this figure out, they're asking, so we know that one of them is 3a plus 8, and we know the other one is 5a plus b. They want to know this third missing side in order to equal this perimeter that was given. Well, if we think about perimeter, we're going to add up the 2 sides that were given, and then we're going to subtract that from the perimeter, and that's going to leave us the leftover third side. So I'm going to go ahead and add 3a plus 8 plus 5a plus b. So if I add those, that's going to give me 3a and 5a is going to give me 8a. And that we're going to bring down the b and the 8. So we know those 2 sides. So this is 2 sides. So we're going to take the perimeter and we're going to subtract the 2 sides that we know. So we're going to take 10a plus 3b plus 12. We're going to subtract 8a plus b plus 8. And again, I would distribute the negative. So this is going to become 10a plus 3b plus 12 plus negative 8a minus b minus 8. So I have 10a and negative 8a. That's going to equal, so my third side is going to be 2a. Then I have 3b and negative b, so that's going to give me 2b. And then finally, I have 12 minus 8, which is going to be plus 4. So my third side is 2a plus 2b plus 4. And if you add these back together, it should equal my perimeter. So 3a and 5a and 2a, so 5 and 3 is going to give me 8, 9, 10, which it is 10a. Then I have b plus 2b gives me 3b, and then 8 plus 4 gives me 12. So if I add them back together and check, it should equal the perimeter. All right, so for this one, for a rectangle, I have a length of 3x plus 4, and I have a perimeter. So again, they have given me the perimeter. So they're going to be asking us to work backwards. What is the width of the rectangle? So let's look at this and let's think about this logically. So I have a rectangle, and I know that my length is 3x plus 4. Okay, well that's great. I also know this is 3x plus 4. What they want us to find is the width. So the width is going to be one of these sides. But what happens is if I add up my length and I subtract it, I'm going to get both of these sides. So in the end, we're going to have to divide by 2 because we're going to have 2 of the sides. So I'm going to need to divide by 2 in order to get one of the sides. So I'm going to start by adding up my 2 sides that I already have. All right, so I'm going to add 3x plus 4, and I'm going to multiply that by 2 because they're 2 of the same. And that's going to give me 6x plus 4. So now I'm going to take the perimeter and subtract the 2 sides. So my perimeter was 10x plus 18, and we're going to subtract 6x plus 4. And that's going to leave me the 2 sides in purple that I've highlighted. So distribute that negative. So we have 10x plus 18 plus negative 6x minus 4. And then we're going to do some combining of like terms. So I have 10x and negative 6x. So that's going to give me 4x. And then I have 18 and negative 4, which is going to give me plus 14. Now, this right here, okay, this right here is both sides. It's both of them combined together. I don't want both sides. I just want one width. So in order to handle this problem and actually find the correct answer, we are going to divide this by 2. Why are we going to divide it by 2? Because then it's going to give me one side. So 4 divided by 2 is going to give me 2x. 14 divided by 2 is going to be 7. So my width of one side is 2x plus 7. So remember, when you combine like terms, they have to have the same variable, the same exponent. We want to make sure that my polynomials, they're in standard order, which are ordered from greatest to least. And when we're doing perimeter means we add up all the sides, or if we're working backwards, we subtract the sides from the perimeter